Okay, today I'm going to show how to, oh, okay. I'm going to demonstrate how to create libraries. Libraries are commonly used. You already been using them by using the import statement. So if you type in import math and then say math.sign, that gives you the sign function from the library. We can actually make our own libraries, and basically any Python program can be imported as a library. So if you were to maybe make this file called mylibrary.py, it said print hello from my library, and then import it, it would actually, and you'd save it. The key is that your library file has to be in the same folder as your program. So my program is this one down here, which is importing the library, and the library is mylibrary.py up here. Once you have that, as soon as you import it, you'll notice that it'll run. Now, add a second import function or any import statement, and you'll notice that it actually only runs one time. And the reason is that import statements are set up to basically do the import one time only. And that's because we're actually eventually going to use it to define functions. And it's a bad idea to redefine functions. So we only do it once. And another reason for this is that we sometimes have libraries that import libraries and then other libraries that import those same libraries, and we don't want them to be redefined multiple times. So for efficiency, libraries will only execute one time when they're imported. Now, normally we don't have code in libraries that runs when you import. Usually we use our libraries just to, oh, sorry about that, I had a technical problem. So our libraries usually only run once, and they're usually used to store functions. So let's try this. Let's create a library that defines our Fibonacci sequence. Our Fibonacci sequence takes in a number. We start off with a list with a 0 and 1, and then we iterate through it, and we saw this function before. It keeps appending the sum of the previous two numbers until we get a Fibonacci sequence. So after you create that, save it, and then run it, and at the command line say import my library. So save it as my library, and then you can execute the function mylibrary.fibs.5, and you'll notice that you now have access to this function once you import the library, just like you do with the math library. So we could use this approach to store any number of functions and make basically library functions. You can also use this to create a library of classes. And in fact, in the next program, what you'll do is you will take your class, put it in a library, and then import your class, from that library and use it as a library. So that's how you create your own library. In addition, this chapter goes over some of the libraries that are available to you through the standard libraries that get installed with Python. There's the file input library, which we're going to learn about later in chapter 11, that we'll use in order to save and retrieve data from files. There's the time library that allows us to read time. Notice that the time library represents time in Python as a time tuple, and it's got these 12 elements. To decode those, there's a table in your book that explains it. The first element is the year, the next is a month, day, hour, minutes, and seconds. And then you have an indicator for the weekday, the Julian day, and the daylight savings time. And notice that the ranges depend. For example, months is 1 through 12, but sometimes they start with zeros. Hours 0 through 23, minutes are 0 through 59, and seconds are 0 through 61. And the reason why it goes to 61 is because you do have leap seconds in some years. And then weekdays are 0 through 6, with Monday starting at 0. So you have to know what those are. The time library also has some other functions. If we pass in a time tuple to ASC time, it will convert that tuple into a human readable string. We can also pass in a number of seconds to local time, and it'll convert those seconds to a date tuple. And we have a time function which turns the seconds from the epoch time. So if you pass this time to the ASC time, it would give you the current time. Actually, by default, ASC time does that automatically. So, or actually, if you pass time to local time, it'll give you a time tuple for the local time, and then if you pass that to ASC time, you would get the current time. If you just look at time.asc time, notice that these are optional parameters. By default, it returns the current time. And then there's a number of other functions in here. For example, you can parse time into different formats, and there's a sleep function which allows you to pause the computer for a certain period of time. The random module you've already used, and you probably used random range, but notice that there's a whole bunch of functions in the random library. You can get random bits, which returns a long integer. Uniform function returns a real number, a floating point number between A and B. The choice, if we pass in a sequence to the choice function, it'll actually randomly select one from there. So you could have actually used that for your rock, paper, scissors game. And then shuffle, if you want to make a card game, you pass a sequence in and it'll randomly shuffle that sequence. And sample, it will choose, rather than just choosing one item, it'll choose say 5 items. So if you want to make a card game, you could use that to pull the cards that you wanted from the deck. So here's an example of the random. You've already done this, but if we wanted to represent a dice roll between 1 and 6, remember it's inclusive, exclusive, and this, if you keep running this, that will keep generating random numbers between 1 and 6. And there's other modules. difflib allows you to compare how similar two sequences are. You have an MD5 and SHA libraries that allows you to calculate a hash on a file. And that can be used to determine if two files are the same file. CSV is short for comma separated value. It can be used to read tabular data from a file. Time IT is a tool for measuring time a piece of run. You can't use the time at the start of your program running and end of a program run, because you have to see uh, if because your program is being only a little bit of time by the operating system, and other processes are running in the background. So just to find out what your program is doing, you have to use the time IT library. There's a profile module that also can the efficiency of a piece of code, and there's a trace module can give you coverage analysis for which parts of your code are executed and which are not. And then date time, if the time module isn't enough for your time tracking, there's a better date time module. And iter tools, we don't get into iterators that much in this course, but there's one for those. And then logging. Often when we're right now when we catch an exception, we just basically report the exception to the user, but you could use the logging library in order to log to a log file. And then there's a regular expression library. Regular expressions can allow you to analyze a pattern of some text. So, for example, you could use it to determine if a piece of text is actually in the format of a phone number or a serial number. And then the shell function. After we do work with a file, you might want to look back at the shell function. It's kind of a simplified way of storing information. It gives you a shelf object, and you can store things in it just like a dictionary, and it will automatically save it at the end of your program. So this could be really useful for storing, for example, user preferences. And so that concludes what we have on libraries, and thank you very much.